have a table of values with two entries, and those entries involve T and H. Yeah, any two letters except for X and Y, really. All right. And let's say one of those values, or one of those ordered pairs is 0, 11, and the other is, let's say, 3, and I'll go with 12.5. All right, something not too complicated, but not too clean either. All right. So if I want to write the equation of a line passing through these 2 points, I would want to follow the model of y equals mx plus b, right? But it's not really y, and it's not really x. It's just placeholders for y and x. All right? The t is taking on the role of x, and the h is taking on the role of y. All right? So when I find the slope is normally change in y over change in x. All right? The change in y is really going to be, in this case, the change in the quote-unquote y. I'll put a little quote-unquote there. All right? So in this context, it's really the same as saying the change in the h values over the change in the t values. We're changing our variables. All right? They're still following the same form, but it's different letters. All right? So what I would do is I'd subtract. And you can subtract in whatever order you want as long as you're consistent. I'll do 11 minus 12.5. And then I'll do, in the same order of subtraction, 0 minus 3. All right? So we're looking at, this is negative 1.5 over negative 3, which simplifies down to 1/2 or 0.5. All right? A lot cleaner than the numbers you're getting, but when I make up an example, that's the price we pay. All right? So now for the y-intercept, the b value. All right? So that's another quote-unquote, because you have another b, and that b is referencing something else in the activity. All right? This b value here is the y-intercept. So this m is the slope. This b here is the y-intercept. So more than anything, we're learning how to keep track of different variables and what their responsibilities and roles are within each context. In this case, the context being I don't know. TikTok, maybe? I can't tell. So anyway, we identify the y-intercept by locating the x value that it's equal to 0. All right, so to find the y-intercept, that's a weird looking y. I gotta fix that. Locate the x value of 0 and identify corresponding value of y, quote unquote y. All right, so a lot of quote unquotes here, but still it's the same idea. I highlighted the x value of 0. That x value of 0 corresponds to a y value of 11. All right, but x and y is really t and h. So again, you got to keep track of it. But long story short, it's telling us our y-intercept is equal to 11. All right. So under normal circumstances, I'd say y equals 1/2 x plus 11. But our variables here aren't x and y, they're t and h. So h would be equal to 1/2 t plus 11. All right. Now, you don't want to do all this. Now, a lot of this is notes, but you don't want to do all this without being able to check your work. So how do you check your work? Well, there's a couple of ways to do it, but one nice, convenient way on Desmos involves making a table. All right. You saw that we drew a table, or I drew a table here. you have tables in your activity, Desmos will create a table. You tap on that little plus sign. You see the one that says table. It's labeled X1, Y1, so another set of variables to worry about, but just put in the numbers. Doesn't matter what the column headings are. 0, 11, 3, and 12.5. All right. If you do a little pinch zoom action there, you see the 2 points are plotted. All right. You can do that with your points. Now, what I would do is type in the equation in terms of x's and y's. So y equals 1/2 x plus 11, and make sure that that line goes through the 2 points that I plotted. If it does, I'm in good shape. I mean, I'm in more than good shape. I did it right.